Hello, today we're going to discuss how optimization algorithms are making transportation and supply chains more sustainable. Modern society depends on transportation networks, global supply chains, and e-commerce logistics to move and deliver goods. However, these systems consume enormous amounts of resources, and even small inefficiencies can create major problems such as higher emissions and rising costs. To address these challenges, companies are increasingly using optimization algorithms and artificial intelligence. And in fact, a 2025 KPMG report found that 96% of firms reported operational efficiency improvements from AI adoption. In this context, optimization means finding the best possible solution while operating under constraints such as warehouse capacity and budget limits. Tools like linear programming, graph algorithms, machine learning, and dynamic optimization help firms make faster, smarter, and more adaptive decisions. An example of this is Amazon's AI-driven supply chain. Amazon manages millions of products every day. Its main challenge is deciding what customers will buy, where to store the products, and how to deliver them. The system works in three steps. First, machine learning models forecast demand using historical sales data and browsing behavior. Second, inventory optimization determines how much stock each warehouse should hold. And third, route optimization moves products while minimizing cost and delay. As shown here, Amazon also uses AI-powered procurement systems to automatically generate purchase orders, route approvals, and match invoices with deliveries. And this reduces manual work, delays, and excess inventory, demonstrating how optimization can make supply chains more efficient and sustainable.
This is an example of UPS. UPS delivers over 20 million packages daily across 125,000 vehicles. So coordinating the efficiency is not a simple task. The Orion system tackled this by solving what mathematicians call the vehicle routing problem. The goal is to minimize the travel costs across all drivers while ensuring every stop is visited exactly once, every driver departs and returns to the depot, and no vehicle exceeds its load capacity. Because the number of possible route combination grows faster with each added stop, finding the perfect solution is computationally impossible at USPS scale. So Orion uses heuristic or smart approximation method to find near optimal routes in real time. Next. And the results speaks for themselves. Orion eliminates 100 million miles of driving per year, cuts 10 million gallons of fuel consumption, and reduces carbon emissions by 100,000 metric tons annually. It is a strong example of how mathematical optimization applied at scale can drive meaningful environmental impacts. Next. And this is an example using linear and integer programming to optimize the route system in USPS Orion system.
So we can see that both Amazon and UPS are working under constraints. And while it's inventory or routing, both of them are balancing the cost, speed, and their sustainability. Next. So these systems don't really work on removing the problem, but they are redistributing them. Companies are trading off cost, privacy, and flexibility for more efficiency. So, an optimization works on a new layer of complexity rather than fully removing it. Next. To conclude, as our systems scale, sustainability becomes less about producing more and more, but rather about optimizing with what we already have. And that's why problems are increasingly computational in the two examples that we discussed. Thank you.